Hello, good morning to you. How's it going today? Top of the morning. Spring is about here. I'm very excited about it. Got to a whole whopping 60 degrees the other day, a proverbial heat wave here in the Midwest. Although, in retrospect, our winter was pretty tame compared to some of the places here in North America. So I'm gonna count my blessings. 1, 2. Anyway. Oh, well, with spring comes the attack of the flea markets. Everybody's had all winter to accumulate a whole load of crap that they don't want anymore, or have time to reflect on junk they don't want to have around anymore. So the first spring flea market was a ham flea market, about 39 miles to the east of me, roughly. Just a little short drive, and all sorts of ham goodies. I got some ham goodies. Well, it's ham related. How about that? Anyway, first up is the RCA VTVM, the WV-98C, or kind of lovingly known as the Voltohmyst, the senior Voltohmyst. You know, I've never really paid a lot of attention to the senior Voltohmyst. I knew that people liked them. That you see them quite a bit. That's my wife's. You see them on eBay and other places, and guys are always grabbing them up. And I never paid any attention to the thing. I'd seen one there, and I picked it up. Well, I don't know why people pay attention to them. This case is a cast case. You could probably drop that from space and put a hell of a dent in the earth. Now, word of warning. I usually don't have too many words of warning, but this actually is almost all true VTVMs. The ground lead is actually hooked to the case. And if you get to using it on something that doesn't have an isolation transformer, or that has a hot chassis, and you run afoul of hooking it up and get it wrong, this will turn into a kind of a cool little flamethrower. And it may have already done so now. I think that's just a tear. No big deal. The cat's pestering me to go outside. It is nice out today. Maybe I'll break down. So if you hook this to the case, and the case has a hot chassis, and this is grounded, bad things can happen. So just a little friendly word of warning. I don't know if this works. The guy wanted 20 bucks. Do you think I paid 20 bucks for that? Haha, foolish earth people. It's 10 bucks. You gotta try. I mean, worst they can say is no. We might have a video about good old haggling. Little housekeeping is in order here. Actually, the Voltohmyst is a pretty nice meter. It's pretty big. I mean, it's as big as your hand. You could put that on your bench, on your shelf. Okay, my voice isn't changing. And you can see that baby. I could see that from here. I'm back, I don't know, 4 foot. And it's readily visible. So maybe this year we'll start off with some maybe better information. Anyway, what this is a product called Goo Gone. It's some sort of a citrus-based solvent. You know, I'm sure everybody's got something. Anyway, I'm just going to carefully wipe that on. There was a sticker up there, too. This stuff is pretty inert, so I'm not too worried about it dissolving the face of this. Although, if you're unfamiliar with a new product, you may want to test it in a corner. Maybe a good test for that would have been maybe up here. There's a little lip there. But I'm fairly confident. This stuff eats about everything. This eats a lot of grease and oil and a lot of different stuff. There's some other variations of Goo Gone. I don't get anything from Goo Gone. It's just a product I use and I like it. So I'm going to mention its name. How's that sound? And if you work for the Goo Gone company and want to send me a couple $1 million for my endorsement, I'm not going to complain. sorry, I had a big bowl of cereal today and it had some sugar in it, so I'm pretty wound up. How's that sound? It's the way it is. So, almost all, but not quite, vacuum tube voltmeters have these probes. Some of them, you just about have to have the probe. Let me back up a tick here. There we go. And you just about need that probe. And this particular one, has what they call the mic connector. I believe Amphenol invented this damnable connector. A lot of older test equipment has, you can't go outside. A lot of older test equipment has this connector. I go out of my way to change this unless a couple things happen. Unless it's on something like this, which I kind of like the look of this. It's just the way it is. Or it might be a big pain. This might be a pain. Another connector you see on vacuum tube voltmeters is the 1/4 inch banana plug. That's not uncommon, and those don't bother me so much. So if you go to buy a voltmeter, make sure you get this, or make sure you know what kind of a probe that might be needed. Inside this one is a big resistor, I believe a megohm resistor, so nothing major. This is kind of an interesting tip too, because I believe RCA made some accessories that just snap on this tip, and then you don't need a whole other probe. Like their RF probe, I believe, just snaps on there. And I believe this tip might be silver plated. It looks like it's a little oxidized. Okay. Well, the first order of business is to pop this baby open and give it a good look. And there's some, looks like there's a control in the back, probably some basic adjustment. We'll get out the little screwdriver. And quite a few videos ago, probably about a couple hundred videos ago, I had kind of a little series where every tool I needed and every part I needed, I pretty much obtained from flea markets or garage sales, and that was met with reasonable success. I might do that again. It's easy enough to do. If you're in a hurry, it's probably not such a great deal, but if you're just taking it easy and having this be a hobby or do something fun, nothing wrong with that. Not everybody has a big wad of cash to throw at their pursuits. So we'll just give that a little lift. Nothing happens. And this also has kind of a weird leather handle on there. Sometimes you see the handles gone off these meters. Nothing major, unless you're dragging your vacuum tube voltmeter around. The other name for the vacuum tube voltmeter is the VTVM, just the abbreviation. Okay, well, it looks like this one's been a little worked on. Nothing to cry about, though. Somebody has much appreciated taking the battery out of the thing, and it looks like they've added a new battery holder. Probably what happened is the old battery holder turned into a corroded mess and they just replaced it. I'm not sure how that's in there. Oh, double stick foam tape. That's okay. It's actually pretty secure. That I call it servo tape. That tape is damn strong. So there's one tube. That is the 12AU7. Almost all these meters are identical. There really are only so many ways to build these. I can only think of a few that are different. The HP, what is that, 410B is a little different. So what do we got here? Looks like some adjustments. That's weird, there's only one adjustment. Ancient circuit board technology. Look, I'm just looking this over just to get a good look at it. I'm trying to see what you'd have to do to take that jack out, and that looks like a big pain in the butt. Looks like you'd have to take that circuit board out and reach down in there. And it looks like, oh, there's a little pilot light right there, a little NE2. A little filter cap, and it might be trouble on the hoof. 10 microfarad at 200 volts. Some of these are point-to-point wiring. You know, there's actually a lot of wiring and resistors in here on the ranges and the functions. And there's another tube in there, and it's, yes, my Mr. Watch. Here's the, what is that, 6AU, 6AL? I can't remember. A 6AL5. It's a twin diode tube. I always keep a few of those tubes around when you run into it. Sometimes you run into these meters and somebody's stolen the tubes out of them. So basically this thing is a big cast box. So that was probably a D cell. Trying to think if I have a D cell floating around. Yes, I actually don't keep that many batteries. Well, so that goes on there. We'll just unwind this, give it a quick looking over. There's a little nick there, but it's a burn. Nothing major. I don't know. I guess there's, kind of says something if you get too many pieces of test equipment with burns. And this just screws on there now. This here is the contact. This is one of the reasons I don't care for these a terrible lot. They just solder that, and they put a little dent on there. And this one's actually made by Switchcraft. I don't know if Switchcraft is still around. Okay, so this one has an ohms AC scale and a DC scale. You know, we can use the AC scale. Vacuum tube voltmeters are usually sensitive enough to pick up kind of AC, low-level AC fields floating in the air. Well, how about 1.5 volts? So the basic functions of this are the voltage range. This one goes from 0.5 volts up to 1,500 volts AC. That's got a pretty good swath. A lot of them stop at 500 or 1,000 volts. The zero set, which sets the scale. There's also a scale here to set the mechanical, or excuse me, anyway, you can set the mechanical zero with that under that door. The ohms high range, and then the function. Off, AC, DC, plus and minus, and resistance. So, oh, that has a selenium rectifier in it too, right? Right there, I just saw that out of the corner of my eye. I don't know, I'm not a big fan of modifying things. A lot of people go out of their way to modify things. I like the look and the feel of this old stuff, so I usually leave it alone unless it's in need of repair. So, we'll just turn it on. The light come on. Yep. It's not super bright, it's very pink. This is a very clean piece. This is kind of nice to get a hold of something. So obviously something's working. The meter slammed to that side. Oh, let's zero her up. Ooh, it's pretty sensitive. So usually you look straight on at that axis. You look, I always, go for here. And then you zero that. We're looking at this at a skew. And it looks, yeah, it's pretty close. Although, see here, right there, it doesn't look like it's zeroed. Oh, let's see here. That's, there we go. Now, to you it looks zeroed. To me, looking straight on, it's off by just a touch. That's a, what is that? Is that parallax error? Yeah. Because you're not looking at something on axis. Okay. Well, So we grab the handy probe and we give it a little touch. Oh, and we got volt. Sweet. So I'm off to the races. Okay. But the bottom scale doesn't work. What do you know? That scale works. There's a good chance that some of these ranges are burned out, especially on the ohms. Well, so far up to, what is that? 150 volts. It appears to work to 500 volts. I don't know if we can't. Yeah, it's not going to measure. Well, it sucks. That lowest range is damaged. Rats. Oh well, it'll give me something to fix. So a quick test for the DC is to get a battery. Let me see if I've got a damn D cell. Well, we can get double duty out of the D cell here, so I'm going to turn to the DC plus range. 1.5 volts. Despite what people think, dry cells or alkaline dry cells aren't 1.5 volts. They're over it by, I think they're like 1.56. So this should theoretically go off scale. We need to switch the probe. Yep, and it's off scale a tiny bit. There's the 5 volt scale. And it reads just a scotch over 1.5. You have to kind of look at the different scales here and use the appropriate scale for the appropriate measurement and function. It's one of the reasons people don't like VTVMs is sometimes a little thinking is involved that makes their head hurt. Okay, so we've done a couple things. The DC scale appears to work. I'll just keep going up till I can't see it move anymore. The input impedance of the voltmeter is so high. My body resistance, is in the megohms, but yet I'm touching this side and using my fingertip, and you can see the meter move there. So there's 50 volts, still moving. There's 150, still moving. I think we went to 500. Yep, it barely moves. So I would say that the ranges are in good shape on this. So I don't know, we'll just turn this off to be safe. Just snap that baby in there. The other thing I've noticed about VTVMs is they're pretty easy on batteries. One thing I do is I usually put a little tiny sticker somewhere. Actually, just sticky tape works pretty good. You can peel it off easy enough and write on it with a Sharpie when you put a battery in there. And if you get to leaving the battery in there too long, just take 10 minutes out of your busy life to save yourself, destroying a valuable piece of equipment and get the battery out of there. So we'll let it warm back up. Probe goes back to the ohm scale. I believe in these probes, all that is a switch, and I believe when it's switched to DC, there's an additional resistance there. I believe it's about a megohm, and then in AC, it's straight through. Okay, so we've let's set the range pretty low here. I don't know, how about, we'll just go with ×1. Okay, so the meter is it's kind of over pinned on this side. And if you look at the very top scale, that is the ohm scale. In ×1, it's up to 1,000 ohms. So you use the ohms adjustment to set that up if your meter's working right. The last pip on this meter anyway is infinity. Now guys have different theories about this. Some of them actually set it over here at the infinity sign. I usually set it at the last mark. You should read the manufacturer's book and see what they say. I've seen it both ways. So when you short the two leads together, it should fly over to the other side. Now it's off here, so we zero that out. And I can give the leads a jiggle there to make sure they're making good contact, fairly good. Yeah, see, it got a little bit better when I tightened that connector. It's naughty, naughty. You can retouch that up with your soldering iron just carefully. Notice when I opened this up, now it's off, so you got to go back and forth a few times. Usually only takes 2 or 3 times. Off a tiny bit, nothing to write home about. Yeah, we're just going to keep doing this till it gets straightened up. Now, the other thing that'll happen too is the tube warms up. This will vary. So there you go. It took, what, I don't know, 3 or 4 times to zero it up. This will change with the ranges too. We'll go to a different range. And here you can see that the zero is already screwed up on there. And yeah, this is one of the reasons people don't like vacuum tube voltmeters. They can be a bit fiddly, but some good VTVMs have a circuit to kind of compensate or take that nastiness out of there, or annoyance more. So it looks like we're ready to go. So all I gotta do is slip the case back on, which is good, because I don't know, to test that cap or to not test that cap. It appears to be functioning. Well, I'll tell you what. We can do a quick test. I'll have to cheat here. I don't think the VTVM can test itself, but we'll just get a... So we'll get out the fluke, and what I'm going to do is just check the ripple. So I'm on the DC scale here. This machine can check ripple, AC ripple. It's got 1.13 volts ripple. So we'll check the actual DC. Excuse me, I was on the AC. So it's 82 volts DC with about a volt ripple. So what is that? Less than 1%? Not bad. Just looking here. So it would be easy enough to change that cap. I think I'm going to tempt fate. I know there's some people out there having a fit. If I'm going to do that, I'm probably going to replace the little selenium rectifier. Keep in mind too that that's half-wave rectification, so it's going to be a little bit ripply. And don't be surprised if your voltmeter won't check AC ripple on the DC scale. A lot of meters don't do that. They get confused. Well, I say we're done, and we're ready to go on to bigger and better things, which I've got this to work on. So now I've got my voltmeter, I'm set. Anyway, thanks for stopping by, and we'll get on to this in a bit. How's that sound? Again, take it easy. Have a groovy day.